Welcome back to another episode of Rail Industry Connected. I'm Dan Clark, and thank you for joining us. We've mentioned on previous episodes of Rail Industry Connected about the challenges faced when introducing technological advancements into the industry. Technology is essential in enhancing and optimizing work, but linking it with human input and using it to enhance and not replace is the key to its success. Today we speak to Tim Flower, the UK Account Director for KONUX, a company providing technological solutions to address railway challenges. Tim is a railway maintenance professional specialising in technology adoption to enhance asset reliability and efficiency. At Network Rail, he led the development and rollout of an automated track inspection, known as PLPR, and secured £190 million for the CP6 Intelligent Infrastructure Programme. He joined KONUX in 2021, initially leading the UK market before expanding to Northern Europe and international business development just last year. Tim, welcome and thank you for joining us.
Thank you for having me.
So, please tell us a bit more about KONUX and why it was formed and what it aims to achieve.
Yeah, so KONUX has been going for pushing towards 11 years now. I was going to say 10, but that was last summer. It was formed out of Munich, TUM University. I think it's Technical University of Munich. It's the English pronunciation, at least. Four friends decided they wanted to create a startup using artificial intelligence, and they went from there. Really, they came up with some ideas, tested them with the market, and eventually ended up working with Deutsche Bahn on a specific solution, looking at how do you measure voids at crossings specifically, or frogs as they call them over there. That then enabled them to get some funding from various sources in Silicon Valley and in Germany, and ultimately led to a rollout of an initial 650 devices in 2021 in Deutsche Bahn. That then enabled us to prove that not only were we effective, but also that we were able to find. I think the target was around 90% of everything the humans were finding as part of their inspection, and I think we achieved around a 95% hit rate. So that enabled lots of success there, which gave us a springboard into the rest of Europe, and that's when I came on board, really. So I joined just after we got that initial contract to try and replicate the success in Germany, in the UK, and been going from there ever since. In terms of what we do, we use an accelerometer-based solution, which we call the KONUX device, that goes to sleep in between trains. As a train comes towards it, it wakes up. It then measures the vibration from that passing train and then goes back to sleep again and does that throughout the day. Every evening it then sends the data off. We then process that data, so the next day you get a really, really comprehensive view of what's happening at the switch or at the crossing, depending on where the user's chosen to apply it. I can talk a little bit more around some of those insights shortly.
Yeah, of course. I think this is a good example of where technology is best used, really. I'm guessing it really supports you from a preventative and planned maintenance perspective, I'm guessing.
Yeah, so the insights we provide, we give a prediction. So,
Yeah.
what do we expect the assets to look like in the next 60 days from a voiding perspective? We give a health rating. So, how is that asset performing compared to all the other assets that a manager has to look at? Because that's one of the biggest issues: is which ones do you treat first? If you've got
Yeah.
200 to look after, you can't look after all 200 at once, or maybe even within a year, really, given the constraints on funding. So we give a health score. We also compare each crossing to all of the crossings in our database. So if you've got a C switch, for example, we will look at all the C switches that are fitted onto concrete bearers. We will look at the train speed. So we calculate the speed of each train as it goes through, and we'll use all those parameters to give what we call a relative acceleration score. And from that, we're able to say, again, for this switch, it's 200% worse than the norm, or this one is actually in really good condition, it's 50% better than the norm. So again, it's giving the engineers much more information than they've ever had about condition of the crossings and the conditions of the crossings under load. Obviously, one of the changes in the UK in the last few years has been only going trackside when the trains aren't running, whether that's taking a line blockage or going into a possession. So the opportunities to understand what's happening under load have reduced as well. So we provide a really nice supplement to any inspection regimes, and we can provide assurance regarding like a reliability centered maintenance regime as well. So there's been lots of work in Network Rail over the past probably 15 years now, bring in reliability centered maintenance in such a way that it enhances the reliability of the assets whilst having no impact on the actual safety of the infrastructure. And whilst inspecting less frequently as well. So it's sort of just three factors involved in that kind of regime, and getting that right is really key to running a safe, reliable railway.
I completely agree. Obviously, one of the challenges here, though, is, as you said, you work wide here. You've got so many different systems to contend with. How do you adapt what you're providing to all those different systems and obviously different challenges as well that they provide?
Yeah, so from a system perspective, we're really keen to work with other suppliers and the
Mm.
infrastructure managers to integrate as much as we can. Obviously, that has its challenges. We're very flexible and agile because we've built it from scratch and it's new. And quite often you're trying to land it in systems that have, some cases, been around for 30 or 40 years. So that creates its own sort of integration challenge with our infrastructure maintainers. But the way we've tackled it from our own perspective is to build something called Delta sharing from Databricks. So we've fully implemented that into our system, and that enables us to give a regular data. We don't actually give you. It enables the infrastructure managers to come and fetch the data that they want from our system. So they say what they want, we give them a key, and they can fetch that on whatever basis they want to. So we're currently integrating into Power BI dashboards in some regions. And the longer term goal will be to provide our data into Network Rail's Insight tool, for example, and also the radar remote condition monitoring sort of alarm and alert tool based on the user feedback and what we're trying to achieve. In Germany, we've got we do it slightly differently. So we use MQTT transmission protocol to send the data to Deutsche Bahn, and that's integrated into their Diana system, which I guess is similar
Right.
to Network Rail's radar system.
That integration is absolutely key, isn't it? It's everyone's using different systems, and AI and technology nowadays is becoming more of, you know, prominent in supporting all aspects on the railway. So we've talked about it from a maintenance perspective. How else are you using it to support the railway infrastructure management, and how can it support businesses working in this sector beyond what we've already discussed?
Yeah, so the goal, the next iteration of the product that we want to build, and I say the product, the data product as opposed to the actual product. So using the same device, but building on the insights and building on data that we can get from the infrastructure maintainers. We want to get to a point where we're able to give a view of remaining useful life. So that then enables asset management decisions to change as well. So we're broadening that from just purely the maintainer to giving the asset managers or the route engineers, as they're called in Network Rail,
Mm,
um, a different view on what's left of how much life that asset has remaining. There are obviously whole life costing systems already in place that Network Rail and others use. We see this as being a nice supplement to that to really help drill down into making sure the right asset gets the right treatment at the right time. The other thing that we're doing in terms of looking more broadly is trying to work with other suppliers um, who have complementary tools. So from a maintenance perspective, we work with we created something called the S&C Alliance, where we bring together suppliers such as Interflon, DWG, Statite, and Intel Rail, and all of them have a different role in helping getting the most out of the asset whilst keeping it running for as long as possible whilst delivering reliability. So that's one aspect we looked at. From a technological perspective, we're working with various companies, looking at, can we integrate video into our system, and how does that help the maintainer understand more around what our insights are telling them, because vibration as a measurement is quite new. So understanding what that means on the ground is a challenge in itself. So we're trying to work on that, and we've been successful with One Big Circle in that area for a piece of research and development for Network Rail that's just finishing actually. Then from another perspective, using our AI tools, we have quite a comprehensive set of AI tools that can be reused for other use cases. So looking at point machine data, for example, being able to reanalyze that and give new and different insights around diagnosis and time to failure. So that's one thing that we're really trying to maximize, and we've already got some success in FNM, which is the Milan commuter railway, in Adif in Spain, which is the company, the infrastructure manager for Spain, and we're hopefully starting to move that into Network Rail in the next few months as well. So that's kind of how we see what we built initially is a set of tools that enable us to record the infrastructure, transmit data from the infrastructure, manage that data in a lake house, which is a new term to me, but I think the techies will understand. And then apply artificial intelligence and machine learning to that data. So looking forward, what we're aiming to do is open up those tools to others that may need, a communications protocol and don't necessarily want to go through all the pain of building themselves if they've got a really nice sensor, for example, or building the lake house because somebody might not want to invest in that particular area. So really, it's around trying to sort of call it democratize the tools that we've got for, I guess, the good of the railway.
That makes sense. I've never heard of a lake house before, as it goes. That's a new term for me as well.
I think
I think
it's
that's
a
a
data
point.
lake, but more structured, I think.
Right, okay. There you go. I've learned something new today. I think that's the point, though, is that we're still in uncharted waters with these technological advancements and everything else. It's all quite new and it's bringing, new things into the industry. On previous episodes that we've done of Rail Industry Connected, we've talked a lot about implementing technology and actually the success of that and where success comes from. And a lot of it from discussions that we've had has been about the onboarding process. And I think you've really touched on a valid point there, is that actually integrating it with existing methods and technologies that we have already in order to have that human input is essential. Where do you see this combining? How have you made it as easy as possible to onboard systems like this into the different systems that you're working across the world?
We have built this flexibility into our system that enable us to get that data to the right place, as required by the end users. I think it is one of the biggest challenges faced by any maintenance engineer, probably in any rail company, is that they had systems from 30 years ago, from 20 years ago, from 10 years ago. Integrating them is difficult because of the way they were built, and therefore to get the answer you're looking for, you might have to log into 5 or 6 different systems. Network Rail have made loads of progress with this, as have Deutsche Bahn with their Diana system. So I think the necessity to bring the data together into a common user experience is recognised by, I think, all the European railways now, and probably further afield as well. It's just the time to actually get there is it is a challenge, and a significant challenge with some of these sort of legacy type systems. Yeah, from our perspective, really, we have built a really nice user interface that is nice, easy to understand. You don't need a huge amount of onboarding. You could learn it yourself if you really wanted to, but obviously
Right.
we also take people through it. So we'll go and sit down with the engineers. We'll spend an hour with them, explaining all the different features, how they work, and how they can integrate into sort of day-to-day business practices. But we've also built a set of smart alerts that can get sent by email. I think that the biggest thing that we've realised is that everybody's different, every office is different, but there's probably 4 or 5 different patterns and ways of working that you need to accommodate to be truly successful. So some quite happily go into the system and play around and dig into each individual asset. Some just want to know which is the worst one, and then there's levels in between. So it's about finding that right pattern. Again, working with the routes, working with the end users to meet their requirements, because even in Network Rail, Sussex have got a slightly different way of operating to, say, East Coast, for example.
Absolutely.
So Sussex were our sort of pathfinders for writing a work instruction. They helped us set the right parameters for when to intervene. They set it up with their control center, so the engineer only gets notified when they need to be notified, which is a really
Mm.
nice way of doing it. So the control center, the infrastructure, sorry, intelligent infrastructure technicians in the control centers triage the data. They check it every day, see if anything's changed, see if there's any alarms, any alerts, and then they raise, if action is required, they raise a fault. And that fault then goes to the maintenance engineer to deal with, according to the timescale set by the route engineer. So it's a nice, simple approach to tackling, which can be quite a difficult problem if you're just starting from scratch and you don't actually know what to do with the data. So it's sort of, and it is paying dividends. We're beginning to find things well before they break. And we apply in what we call, I guess, the Sussex logic across all of Network Rail, is beginning to show around, say, 80% of broken crossings we got precursor
Mm.
indications for, which is a fantastic hit rate.
Nice.
And around, I think it's around 67% of defects, 67% of delay minutes, generally caused by the switch and the point machine failing. Obviously, it's different impacts. But yeah, following those thresholds has moved us in the right direction. The challenge then is to make sure it works on the West Coast Main Line, the East Coast Main Line, because
Absolutely.
acceleration varies with speed, and the route to Brighton is not as fast as the route to Scotland, for example. So we have to really understand our users and what they're trying to manage, to make sure we give them the right insights so that they can be as effective as possible.
But you can see how much of a difference that insight is in terms of effectiveness. You've not got someone going out to, you know, a job that they don't really need to go out on. So you can see from both from a cost benefits analysis and actually just from an efficiency point of view as well, how key that will be going forward. And I think that's the benefit that AI and technology has brought, especially to the rail industry. But where do you see AI in the future of railways? And what do businesses of all sizes need to do to embed technologies like this into their operations? Because you can see the difference it will make, and you can see how companies need to really just get on board and adopt this kind of technology nowadays.
Yeah, absolutely. I mean, I went to a conference earlier in the year, and one of the questions open to the audience was, "Can AI be implemented in railways?" And everybody's like, "Oh no, no, you can't have AI running a train." And it's like, well, yeah, but you're
No,
thinking at the extreme end of the
exactly.
capabilities of AI. AI has many different forms, and it's already been introduced in Network Rail. I mean, machine learning is a form
Mm.
of AI, and we did it for the track inspection project, the PLPR project, and that was introduced, I think, 13 years ago now. So it's not new, and there are, I said, they're not quite well established patterns, but there are patterns that have been used before to actually bring this in and make it work. I think the
Yeah.
first consideration is safety criticality. I don't think you probably would have a SIL4 AI system, not for a little while anyway. I think there'd be a lot of nervousness around signing that
I
off.
think so, yeah.
But for PLPR, I think we got to SIL2. So we could demonstrate, the system replicated what I think the criteria that was set was a competent inspector um, on a good day or something like that. So accepting that humans are fallible as well, because I think
Of
that's
course.
something that everybody forgets when moving in moving forward in these things, is that it's possible to be much better than a human and still not be perfect. And I think
Yes.
that's needs to be part of the acceptance criteria, really. Um, but yeah, for when we did it for track inspection for plane line pattern recognition, we follow the common safety method. It gives you a really nice comprehensive way of demonstrating that what you're introducing is safe. So it can be done. Um, we probably, in hindsight, and obviously that's it's the 13 years of hindsight, you do it differently. Clearly, we tried to replicate what the track inspection handbook said. The track inspection handbook was written for a human to go out weekly,
Yes.
and we were trying to go out 4 weekly with a train, and using algorithms. So. Um, you wouldn't do that again. You'd need to, you'd do a
Us.
bottom up FAMICA analysis of the failure modes you're trying to find, what the timescales is on those, what's the and then you would design your system around that FAMICA, um, which is a really, again, a really good way of building something from the bottom up to deliver what you require. So I think that's sort of the next stage for Network Rail. Speaking to some of the engineers there, that's how they will move it forward and evolve it to become more comprehensive. Because the clues in the name, it is only plain line. How do you transport that into switches and crossings, and how do you bring in other data sources like ours to create a fully comprehensive, reliability centered track inspection regime that means that humans go out to fix stuff rather than going out to find stuff. And that's how I see it evolving in that space. At the other end of the spectrum, from a performance perspective, there's so much opportunity from a reliability perspective. If you're not impacting on safety, um, because you're giving somebody a little bit of extra information that on their next quarterly inspection enables them to do a deeper investigation on one element of the system alongside all the stuff they're already doing, you're going to make the system more reliable. It's a very efficient way of doing it because you're preventing a failure and an additional visit, and you're tying all that together. So that's where we want to go with our point machine solution: is give diagnoses, give longer term insights, um, and that just becomes an extra work order that takes another potentially 5 minutes whilst they're there already, which is hugely efficient and great for performance. And we see the same for train operations. There's definitely huge opportunities in looking at how the schedules are working today, looking at the clashes, looking at the pinch points, all of which are traditionally done, I think on pen and paper to a degree, but in systems that don't have AI applied, so it is all based on human insight. If you could get some algorithms that builds on that and starts to pull things out probably faster than a human can do, that's where the efficiency is. Then be able to create more robust schedules that mean
Mm.
trains aren't delaying each other, which is quite often what happens at the moment.
Yes. No, it is. So, what's next for KONUX then in the next few years?
So we are in the process of creating the next generation of devices that will be lighter and easier to install, and be more flexible in terms of where they can be installed. So we're potentially creating devices to monitor insulated block joints, for example, where we see lots of track circuit type failures, or being able to fit them to or inside of point machines if we can make them small enough so that you can then understand the vibration that's happening at the point machine, which is caused by the track, but then obviously can be almost like a springboard effect by the time it gets to the point machine. So we already monitor the track at those areas, but I think having a direct monitor on the point machine could be huge in terms of
Mm.
preventing vibration causing failures. And then the next stage really is our platform, which we are going to be introducing at RIA, the RIA Innovation event next week. So we've got a stand there. We're going to talk around what we are going to be able to offer the marketplace to support them in terms of delivering remote condition monitoring solutions. We don't want to build everything. There's loads of good solutions out there, but we would like to be part of making it more efficient for our customers as a whole, which then means the business case improves, which then means they buy more sensors, and then the railway becomes even more reliable and efficient. So trying to create this sort of flywheel effect is what our CTO describes it as, by essentially making it more cost effective, which in turn should mean that more money is spent on it, which is a big goal for us.
Of course. And where, if anyone obviously is interested in KONUX or beyond the RIA Innovation conference next week, where can they go to find out more?
So we have our website, which is www.konux.com. But we're also at numerous industry events. I'll plug those as well if we can. So we have the Rail Live. We have a stand with the S&C Alliance that I talked around earlier. So please come and see us there. The Rise of IoT conference in Cologne is a great event for understanding what the infrastructure managers want across Europe, and I think America as well this time. But also being able to understand, what's the latest innovations, what's the supply chain doing to help the infrastructure managers deliver on their goals. So that's two of the events that we're doing in the next few months.
Amazing. Tim, thank you very much. That was Tim Flower, the UK, Northern America and Australia account director for KONUX. Tim's raised a lot of valid points that we've covered on previous Rail Industry Connected episodes before, talking about how important it is that technology actually works with human input to deliver better results. But you can see from a system like that the actual benefits that putting the right technologies in place have from a cost saving and efficiency point of view. Obviously, from a network rail perspective and across the world, working across different systems is a challenge. But then when you've got an adaptable product, how essential that will be. I think small businesses of any sizes, need to look at technology such as this to really think about how they can implement that into their operations, and how actually that will give them an added edge going forward when they are working on the railways. So, Tim, thank you very much for joining us, and thank you for joining us for another episode of Rail Industry Connected. You can view past and future episodes of Rail Industry Connected on YouTube, or listen to them on your way into work on Spotify. And of course, you can connect with other businesses on railindustryconnect.co.uk. Thank you, and see you next time.